Hello everyone. Today we're doing something completely new and different. We're going to do 3D modeling. This 2D diagram is going to be our reference. So as we can see, it has dimensions, and this is actually the 2D diagram of a cover. These are diameters. Our aim is roughness. This means fillet of radius 5 and 1. This means hole. There are 6 of them, and they all have a diameter 9. This means a chamfer, and yeah, so we're going to use this as a guide to bring our model to life. Not literally. So, so let's begin. First of all, we're going to open up the CAD software. For me, I have NXimen, and so yeah, this video is going to be based on using NXimen to 3D model. Okay, so when you open up your NXimen, you have to create a new file, and we can call this cover one because this is one of many to come. I'm sure we'll do more 3D modeling in the future. Documents, NX, okay. Now we have this. Let's hide. I don't like this here. Let's hide it. Thank you very much. Okay, that's fixed. Okay, so this is our coordinate plane, the datum coordinate system. Z, X, and Y. So we open up the sketch window, we click on it. So it's as you can see, there are 3 views. We have front, right, and top view. What do they signify? Well, in engineering graphics and drawing, we believe that these 3 views are enough to summarize information about a body, in our case, an object. So because we believe the right view and the left view is really similar, the top view and the bottom view also similar, and front and back is similar. However, if there are information that cannot be shown on the front, right, or top view, you can add it maybe to the left, to the bottom, or to the back. But most of the time, these 3 views are more than enough to summarize the information about an object. So we're going to click on anyone because right now we are not really summarizing anything. We're just going to draw and create a model, and we're not assembling. So we're just going to click on the front view. Okay, this is the front. So to begin, first of all, we have to create a reference point. So the reference point, in my case, I like to think of it as a line that is dividing our 2D diagram in half. Like it just runs straight across like this. So, sorry, this is not straight, but straight across. And we're going to be focusing on one part, either this one or this one, because it's symmetrical. In our case, we're going to look at the down part because it's much easier to focus on. But if it's okay with you, you can do the top part. So we're going to draw this part. For every 3D modeling, or 3D model, your foundation must be perfect. And in our case, the foundation is our sketch. If you don't have a good sketch, you won't have the results that you want. So let's create our reference line now. So we just draw a straight line across. It can be left, it can be right, whatever you desire. And we right click on our mouse, and as you can see, convert to reference. So now we convert to reference. After we convert to reference, we can begin our sketch. So as you can see from here, Let's zoom in a bit. It goes up, left, down, right, up, right, up, left, up, and then left to connect to the point where we started. So it doesn't matter how you start. You can start this way or this way, but it should look like something similar to this. And what will make it perfect at the end is when we put in our dimensions. Now, an important fact to know, because of the reference line that we created here, the diameters here will be splitted in half. That means on this side, because we're just doing half of the sketch, so here it will be 75. 75, half of 150. Here to be 52, here 31, and so on and so forth. So just to keep that in mind, only diameters or dimensions showing the horizontal part won't be splitted because it's just showing the downward part, not from left to right, and see it's crossing over the reference line. So yeah, that's just an important thing to note. Let's begin our rough sketch. So I like to use a profile because it's continuous. I don't need to stop and start. It just, once I just click on it like this, it just continues in whatever direction I want it to go. So I left click to begin. As I said before, we're just doing a rough sketch, and our dimension is what is going to bring it all together. So remember, it went like this, like this, like this. Mm-hmm. Mm-hmm. And then finally, mhm. So this is our rough sketch. We have this. It's not perfect, but we're going to make it into perfection. All right, so let's begin to put in dimensions. Now, to put dimensions, we have this, what we call it the rapid dimension. When you click on it, it has different measurement method. They are inferred, horizontal, vertical, from point to point, perpendicular, cylindrical, angular, radial, diametral. So here we're not going to use diameter and radial and angular because we're not dealing with circles or anything relating to that. Even we're not going to use cylindrical, nor perpendicular, nor point to point. Our main use will be vertical or horizontal. So now let's go back to our 2D diagram to look at the dimensions so we can know where to start from. Okay. Now we can start with the first one, 62. So, which is from this point to our reference point. We're not going to do the whole 62, just from the start of this top part to this part. And as I told you, we're dividing it in half. So if you don't want to do mental maths, because who doesn't like a little bit of shortcut, we can use division on our measurement method. How? Okay. So first of all, we click the method. We're doing vertical, and we select the first object, which is our reference, and then the second object, which is this part. And we have this. So we left click two times, and we're given this box. So in the box, we can put 62 divided on 2. We press enter. Yes. So it will ask you if you want to start the formula with an equal to sign, because it will ask you if you wanted to have an equal to sign showing dimension, or if you just wanted to just put the figure. So for now, we're going to put yes, so that you can see what it looks like. So here, it gave us an equal to sign as a dimension. So we have that. We've done our first dimension. Great. We move on to the next one. So we see um, from this part to this part. So we're not going to go all the way. We're just going from here to here. But I like to start from one after the other. Like we cannot just jump from here to here, else we'll have a, a problem in our sketch. I will do it and I will show you what I mean. So we're just gonna put a dimension from 100 from 104, half of 104, and you will see what will happen. So vertical, this part and this part, and we can put 104 divided on 2. So we can put no. So see, it doesn't give us any equal to sign. So because of we took a huge gap in putting the dimensions, it crossed over itself because there is no constraints. So that's why when you're giving dimensions, you have to start off simple and start off simple and then to the difficult ones. Start off easy and start from the small ones before you get to the bigger ones. That's what I wanted to say. So that you don't have issues with your diagrams. So Ctrl Z and we delete this for now. We'll put it later, but just not now. So we put in the dimension of here to here because this we have to create like constraint here, not like a fixed constraint, but like just like something to hold it so that when we put in our dimension here, they don't cross into one another. So as we can see from here like this to this part, it's 85. So half of 85. That's what we're going to use. So we put in the dimensions here. Rapid dimension, vertical, 1 and 2, half of 85. No. So we have this figure. Now we can put in the initial dimension we wanted to do, which was what? 104, half of 104. We can now put this. But see, I almost made the same mistake again. See, if you notice, there is a gap between this part and this part. So these will surely cross into this one. So that means we have to put a dimension here, 96 for this part. Okay, half of 96. So let's do it. It seems to me that we may have forgotten to put in a little bit of detail here. So that's an easy fix. We can just trim out this part and get in our profile tool, extend from here to here. Uh-huh, uh-huh, and now our drawing is fixed. Because if you notice over here, there is a part here that we forgot to add. We just went straight like diagonal and down, but we're supposed to go down and connect. So now that we have fixed it. Okay, so now we can put the dimension here and here, which is half of 96. Let's do it. Rapid dimensions here and here. 96 divided on 2. Nope. And now we can finally put in for this part 104. Let's do it here and here. So Because we were able to give fixed dimensions here, it didn't cross into one another. So that's a good sign, and that's what we should be hoping for. So next, we put the dimension from here and then here. That will be our last vertical dimension assignment. Okay, so we do with this part first, which is 110 divided by 2, and then finally 150 divided on 2. So let's go back. Rapid dimension, here and here, and here and here. Beautiful. So now we can begin the horizontal dimensions. Okay, so it's not a lot. We have 6, 7, 7, 13. Okay, that's a lot. Okay, 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 okay. So we can start with the up one first so that maybe we don't get confused, which is this part between here and here. So let's do that. So we can assign change from method to horizontal, and we click here and here, and it's 6, right? Sorry, it's 7, not 6, and it's 7, 7. Okay, so no need for alarm. We can always trim this out like so. Aha. And now we look again. We give dimensions from here to here, which is 6. From here to here. So rapid dimension, horizontal, here and here. Put in the value 6. And we go back again. Here and here, we have a dimension 7. So here to here, rapid dimension, here and here, 7. So let's look up, because we're doing both up and down. So in this section, we have 13. So we have to put 13 here. And then finally, we crown it as 24. So rapid dimension from here to here. And we put it as 13. And we give rapid dimension from here to here. And we give 24. So we have this as our final result for dimension placement. Let's put it side. Oh, we could have just put it side by side in the initial. Okay, so we have this. That's amazing. It looks almost perfect. So now we have to add in the little details, which is the chamfer and the fillet. So remember I said it's symmetrical. Some measurements you may not see here, but it's displayed here. It means it's the same. Unless you see a different figure here, that means it's different. So provided is listed here, that means it's also distinct for here. So we're going to fillet. We're going to fillet this part with a radius 5. And we're going to fillet this part, this part here with a radius 1. So we're filleting here with radius 1, and we're filleting here with radius 5. So you can easily find it here, fillet. So it creates a fillet between two curves. We select our curves, 1 and 2. And in the box, we put radius 5 and click enter. And now we also put for here and here, and we in the box we put 1 and we click enter. So we have our fillet. Ta-da! And finally, if you noticed, in the same diagram, we have what we call the chamfer. It was chamfered here at this end and at this corner, at the corners, sorry, not in, at the corners. Here and here we have a chamfer 1 by 45 degrees. So we create the chamfer here and here, chamfer. So we select 1, 2, and we put 1 for distance, and for degrees we put 45 and click enter. And we create the chamfer for here and here, 1, 45, and we will zoom in and you can see a sharp edge here and here. So we can say that we are done, but we will just put it side by side for a bit of comparison, just in case there may be errors. I think everything should be fine, and we can go on to the next stage. So we have finished our sketch. We convert this from reference to active, and we click on the flag finish. So now we're going to revolve it. It creates a feature by revolving a section about an axis. So we click on revolve and we're going to select our curves. It has been selected for us. So just in case, we'll just repeat it again. So we click on single curve or infinite curves, whatever you want. So we can follow it up, selecting every single one of them. Make sure you don't leave any stone unturned, else it won't revolve, your body won't revolve. Okay, now we specify the vector. We want it to go up, left, right, sorry, not left, up, left, right. Let's use the word, the z-axis, the x-axis, the z-axis, or the y-axis, whatever axis you want. But it won't revolve on some axes, and I will show you. So we'll click the x-axis, we'll specify the point here. So here we go. This is the cover. So imagine if we choose another axis, like we decide to go down. It will tell you it's unable to create revolved body from the specified section and axis and parameters. Let's do it towards ourselves, and then we have this. So any axis you created, mostly you can only do around 2 axes. So these 2 different axes will give you 2 different type of body. So you have to be careful. That's why we have a reference line, so that we don't do what we're not supposed to do. Okay, so let's go back to what is our initial choice. So this. So we click apply and we close. So this is our cover. Okay, so I will end the video here for now, and next time we will do the geometry together, like putting of the holes and everything, the finishing touches. We'll do the finishing touches together. Thank you all so much and have a beautiful and pleasant